Good evening all. In this session we are going to study few basic concepts of acids and bases. So before going into the topic, let us see the dissociation of water, which forms the basis of all the acid base concepts. So water will be always existing as H plus ions and OH minus ions, or H3O plus ions and OH minus ions. So this forms the basic for all acid base concepts is, and there will be always existing a dynamic equilibrium between this H plus ions and OH minus ions. So the first acid base concept was given by the scientist Arrhenius, and according to him, an acid is a substance which when dissolved in water will be producing H plus ions, and base is a substance which produces OH minus ions when dissolved in water. So according to this, H plus ion is an acid, HCl is an acid because when dissolved in water it produces H plus ions, and NaOH is a base because when it is dissolved in water it produces OH minus ions. And it has a limitation, that is, this acid base concept can be explained only in aqueous solution and not in other solvents, and because of this limitation we are passing to the next concept, that is Lowry-Bronsted acid base concept. According to this theory, an acid is a substance that has the capacity to donate H plus ions, and base is a substance that has the capacity to accept H plus ions. So this concept can be applicable to any solvent that has protons in it, not just water. So according to this theory, HCl is an acid because it has the capacity to donate H plus ions, and NH3 is a base because it has the capacity to accept H plus ions. And according to this concept, after donating a H plus ions, that acid will be becoming a weak base, and this acid base pair is known as conjugate acid base pairs. Example, HCl, after donating H plus, it will be becoming a minus Cl minus ions, and this Cl minus ion is known as a conjugate base of HCl acid. This conjugate acid base pair differs from each other by a H plus ion. And the next concept is given by the scientist Lewis, which is based upon the electron pair donator and acceptor. According to him, a Lewis acid is a substance that has a capacity to accept a pair of electron, and Lewis base is a substance that has the capacity to donate a pair of electrons. So the example for this concept is BF3 and ammonia. When these two substances react with each other, BF3, which is an acid, has the capacity to accept the pair of electrons from ammonia, and NH3, since it is donating a pair of electrons to BF3, it behaves as a base, and both together they form an adduct. So this concept can be explained without the help of the protons, and this concept can be applicable to many substances, and many substances can be distinguished as acids and bases based on this theory. So these are the three basic concepts that explains or outlines the idea of acid bases in a simple way, and we are going to see few topics that relates to acid base concept. The next one is the pH scale. A pH scale is a scale which defines a substance, which is used to define a substance as a acid or base. So the scale ranges from 0 to 14, and if a substance has a pH value below 7, and that substance is categorized as an acid, and if a substance has pH above 7, it is categorized as a base, and if the pH is equal to 7, it is known as a neutral substance. So all the acids will be having a pH range from 0 to 7, and bases, for bases the pH range will be from 7 to above 7 to 14, and if the solution is neutral, it is equal to 7, and water has the pH of 7, which is a neutral medium. So pH scale is used to define a substance as acid or base, and this can be found out using a formula, that is pH is equal to minus log of H plus ions, By knowing the concentration of H plus ions, we can define a substance as an acid or a base. The next concept related to this is ionic product of water. This is nothing but when water is dissociated, it will be producing H plus ions and OH minus ions. The product of the concentration of H plus ions and OH minus ions is given by the symbol Kw, which is equal to ionic product of water, and always it is equal to a constant, that is 1 into 10 power minus 14 mole square per liter square. So this ionic product of water, since always water remains in auto-ionization process, that it produces equal number of H plus ions and OH minus ions, the ionic product is always constant for a water, and this concept is used in many industries. The next concept is common ion effect. The common ion effect, it is also used to prepare buffer solution. So buffer solutions are the solutions which are used to maintain the pH of a particular reaction during a chemical reactions. Okay. To maintain a pH, we need to add a solution, that is buffer solution, that is made up of a weak acid and its salt and a weak base and its salt. So when the dissociation is usually affected by the presence of common ion, and that effect is known as common ion effect. Usually weak electrolytes will be dissociated partially, and if there are some common ions present in the solution, further the dissociation will be affected. For example, acetic acid is a weak acid, it dissociates partially, that is complete dissociation will not be taking place in a weak acid. And further, if there is acetate ion in the solution, that also affects the dissociation of that particular electrolyte, and this effect is known as common ion effect. That is, the common ion which is present in a particular solution will affect the dissociation of the weak electrolyte, and this effect is known as common ion effect. And this common ion effect is used to design buffer solutions using this equation, Henderson-Hasselbalch equation, that is pH is equal to pKa plus log concentration of the anion by concentration of the acid. By knowing the pH, we can prepare the buffer solution. So here we have studied a few concepts related to acid and bases, and that can be related to the formation of acid rain. So acid rain is common in an environment where it is highly polluted. So the Arrhenius concept can be applied to acid rain formation, that is in atmosphere which contains SO2 ions. The water, the clouds will be acting as an acid, and it donates the H plus ions, and the SO2 will be converted into H2SO3. Here water acts as an Arrhenius acid. In step 2, this formed H2SO3 will be donating H plus ions, and it acts as an acid according to Lowry-Bronsted concept. And because of the liberation of H plus ions, the pH of the rainwater goes below 7, that is 4.3, and hence the pure rainwater becomes acidic in nature. And again, according to Lewis concept, the SO3 that is present in the atmosphere, that is formed by the oxidation of SO2, accepts the electron pair from the water and becomes, it is converted into sulfuric acid, which is a powerful Lewis acid, which is the main constant of the acid rain. So in the formation of the acid rain, the three concepts can be explained easily, and because of the acid rain, there are many environmental issues that can be prevented by creating a pollution-free environment. And hence, in this session, we have studied the basic concepts of the acid and bases, and in next session we can study detailed each concept in detail. Thank you.